to transform this double integral from x simple to y simple. Okay, so x simple, I have two numbers for y, two functions for x. In order to translate into a y simple region, I need two numbers for x and two functions for y. Usually, if you're doing this type of problems, you don't have to draw the region. But if you're translating it back and forth between x simple and y simple region, it will be much more helpful for you to draw the intervening region. You don't have to be super precise, but at least you have to be able to tell the curves bounding the region. Okay, so in this double integral, y is bounded between 0 and 81. So this is my 0, this is my 81. So I have a left function y is equal, or x is equal to y divided by 9. So it's going to be passing through 0, 0 with slope 1/9. So this is going to be my left curve. So this is x is equal to y divided by 9, right? So it's going to be passing through 0, 0 and 9, 81, right? X is equal to 9, y is equal to 81. And the right curve is going to be x is equal to square root of y, all right? So it is still going to pass through 0, 0, and when y is equal to 81, x is equal to 9. So these two will actually meet at this point, okay? So this is the curve. X is equal to square root of y, all right? X is equal to square root of y, so y is equal to x squared. So it is indeed a problem opening upwards. Are you with me? So it is bounded between these two numbers. This curve is to the left, this curve is to the right. So this very slim region is indeed the integrating region. Are you with me? Completely convinced. Completely convinced. Okay? So these questions are not very complicated, but you have to be very clear in the geometric relations between this. Which one is to the left, which one is to the right, which one is bounded above, which one is bounded below. And this region is the only choice for this R here. So I want to reinterpret this region by choosing two numbers for x and two functions for y. Two numbers for x. It is bounded between 0 and 9. I need a upper function and a lower function. The upper function is going to be this straight line, right? You cannot go upper than this straight line. The lower function is going to be this curve. You cannot go lower than this curve, right? You cannot go lower than this curve. Some people are confused about why it is upper, why it is lower. You can just see whether this region is bounded above or below by these two curves. Okay? So I need an equation of this straight line, but in terms of x equals something for y, I want y equals something for x. So this is going to be y is equal to 9x. So the only thing you're doing here is to rewrite this equation in terms of x. Okay? And then I need another equation giving y is equal to x squared. So y is equal to x squared. So essentially you need an integration from 9x to x squared. Okay? So this is will be how you do it. So you don't have to be extremely precise about drawing these curves, but at least you have to be super clear. Am I doing something wrong? Yeah.
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 9x should be at the top. Yeah.
Oh, okay. I see. Yeah, you're absolutely correct. Yeah. The lower function is actually this function. The upper function is 9x. Yeah. Thank you. Thank you very much for pointing out. Yeah. The lower function is not the function exactly. So I have to be also super careful about these geometric relations between these boundaries and the region. Okay. So, in my opinion, you definitely have to practice a lot for this x simple region and y simple region. And one of the most important things about this translation is some of the double integrals will be much easier in one of the representations here. So that is one of the motivations why we want to translate back and forth. When we go beyond into triple integrals, this x simple and y simple region will come back again. Okay, so they will come back again. So we definitely want to master the whole skill over here. Okay, so yes, you are.